Alright, again, looking at simplifying radicals today. First step, we want to remember what are our perfect squares. We're going to write down all of our perfect squares. Okay, perfect squares. The more we recognize, the quicker it will go. So 12 would be the square root of 144, 11 is the square root of 121, 10 is the square root of 100, 9 is the square root of 81, 8 is the square root of 64, 49, 36, 25, 16, 9, 4, and 1. So the quicker we can recognize that something's a perfect square, the faster we can reduce. So let's go back and let's review what we talked about. Looking at factors of 20, we're going to prime factor this. So factors of 20, factor it into 4 and 5. Now again, we recognize that the square root of 4 is 2. Right, because it breaks down into 2 and 2, so that comes outside the radical, and this becomes 2 square roots of 5. 75, okay, we're looking for factors of 75. So again, looking for factors of 75 would be 15 and 5. We can break down 15 into 5 and 3, so we have our pair of 5s here. That's going to come outside the radical and become 5 square roots of 3. 80 can break down into 8 and 10. 10 can break down into 2 and 5. 8 can break down into 2 and 4. Now again, we recognize that 4 is a perfect square. Okay, we also have this pair of 2's. So outside we have a 2. That 4 becomes a 2 outside. So outside we have 2 times 2. Underneath the radical we still have this square root of 5. So this becomes 4 square roots of 5. Same thing here, 450, we can break that down into 45 and 10. 45 breaks down into 9 and 5. 10 breaks down into 5 and 2. 9 breaks down into 3 and 3, so we have a pair, another pair, with that left over. So outside we've got 3 and 5, that becomes 15 outside, with a 2 underneath the radical. 32 breaks down into 8 and 4. Pair of 4's with 2 left over. 125 breaks down into 5 and 25. We want to break down 25 because that's not prime, so 5 and 5. Pair of 5's with 5 left over. 50 breaks down into 5 and 10. 2 and 5. So here we're prime factor. There is a pair. 2 stays underneath the radical. So this breaks down into 9 and 5. 9 breaks down into 3 and 3, so we know we're bringing that 3 outside. Now, I already have a 2 outside, and I brought a 3 outside. Again, numbers are multiplied outside the radical, so 2 times 3 is 6. Underneath the radical is still that 5. 6 square roots of 5. 8 breaks down into 4 and 2. 2 and 2, so we have a pair. Again, that comes outside. So outside we have a 2 and a 7. Underneath the radical we have another 2. So outside we've got 14, because 2 times 7 is 14. Square root of 2. And lastly, we know that 36 is the perfect square, so that's going to become 6. So outside we have 4 times 6. Nothing underneath the radical, because I used both of those prime factors. I used both of those factors. So here we have 4 times 6, which is 24. Alright, so looking at cube roots. Okay, let's remember our cube roots. First step is to write down all of your perfect cubes. Right, so we know that the cube root of 1 is 1. We know that the cube root of 8 is 2. We know that the cube root of 27 is 3. We know that the cube root of 64 is 4. And the cube root of 125 is 5. Alright, so again, we're looking to factor this, so break it down into its factors. That would become 2 and 2, 2 and 5. Okay, we know we've gone to all of our prime factors. So again, a cube root, we're looking for 3 of the same kind. So I have 3 2's, they come outside. They become 1 couple outside, so I have a 2 outside. Underneath my cube root, I've still got 5 right there, so 2 cube roots of 5. Same thing here, this breaks down into 2 and 81. 81 breaks down into 9 and 9. So let's break these 9s down. So I have a triplet there. We still got this underneath the radical, so a 2 and a 3. So underneath the cube root, we've got 6, because 2 times 3 is 6. Outside, we have this 3 cube roots of 6. Number 13, we're looking at the cube root of 875. Okay, so I know it's divisible by 5 since it ends in a 5, so let's go 5 and 175. Okay, again, 175 is divisible by 5, so 5 and 35. We know 35 is also divisible by 5, 5 and 7. Alright, so those are prime factors, 5 and 7, those are all prime numbers. So I have 3 5s here. That's going to come outside of the cube root and become one number. This 7 is going to stay underneath the cube root. Cube root, not a 7th root. Same thing here, we're looking at 343. We know it's divisible by 7, excuse me. So we get 7 and 49. 49 is also divisible by 7, 7 and 7. So we have that coming outside. So outside we have a 5. We also have a 7 outside now with nothing left. So 5 times 7, 35. Alright, looking at multiplying radicals. Okay, multiplying radicals. We're going to multiply first, then simplify. Multiply first, then simplify. So we've got 2 times 3. It's going to give me the square root of 6. Okay, again, we can look to simplify that if possible, 2 and 3. But it's not possible because those are my prime numbers and I don't have a pair. So the square root of 6 is the answer. But here, I've got the square root of 120. Well, the square root of 120 breaks down into 12 and 10. 10 breaks down into 2 and 5. 12 breaks down into 6 and 2. We break this down into 3 and 2. So again, we're looking for pairs. We have a square root, so we're looking for pairs. So I have a pair of 2's right here. That's going to come outside of the house. So we've got 2 square roots of 3 times 2, which is 6, times 5, which is 30. 2 square roots of 30. Alright, looking at square root of 35 times the square root of 21. Okay, again, we're going to multiply these two numbers, so we get the square root of 735. Alright, now we're looking to break down into its prime factors. We got 5 and 147. 147 breaks down into 7 and 21. 21 breaks down into 7 and 3. So we have our prime factors here, so we're looking for any kind of pairs that can come outside. There's a pair of 7, so it becomes 7. This is underneath the radical, this is underneath the radical, so 3 times 5 is 15. Alright, here we've got 6 cube roots of 40 times 10, which is 400. Alright, so we can take this, and we can say that's 40 and 10. We can say this is 5 and 2. We can say this is 5 and 8. 8 breaks down into 4 and 2. 4 breaks down into 2 and 2. So once again, we're looking for any pairs that we have. So I've got a pair here. I've got a pair here. And I've got a pair of 5s. So there's no factors that I haven't used. So nothing's going to stay. Oops, sorry. We're talking about the cube root. Let's try this again. Ellipses. Alright, so again, this breaks down into 2 and 5. This breaks down into 8 and 5. 8 breaks down into 4 and 2. And 4 breaks down into 2 and 2. Now, we're looking for cube roots. We're looking for 3 of the same number. So here I have 3 2's that can come outside of my cube root. I already had a 6 outside. I've brought a 2 outside. 6 times 2 is 12. Now what's left? I didn't use this 5. I didn't use this 5. I didn't use this 2. So 2 times 5 is 10. Times another 5 is 50. So 12 cube roots of 50. Alright, looking at number 19. Now we have variables here. Okay, again, nothing changes. You're still looking to find a pair of a number or a pair of a variable. So in this case, we have 25. 25 breaks down into 5 and 5. x squared. X squared is x times itself, right? So x times x. Y to the fourth is y times itself 4 times. Okay, so again, we're looking for pairs. So we're looking for 2 of the same number or 2 of the same variable. So here I've got a pair of 5s. That comes outside. Here I've got a pair of x's. That comes outside. A pair of y's and a pair of y's. So what did we bring outside? We brought a 5. We brought an x. We brought a y. We brought a y. There's nothing left underneath in my radical. Alright, so now this does not look right. 5xy. We could write it as 5xy squared because y times itself is y squared. Alright, let's go to this one. So looking at number 20, we're looking at 18. 18 breaks down into 9 and 2. 9 breaks down to 3 and 3. A cubed is a times itself 3 times. B squared is b times itself twice, so b and b. So again, we're looking for pairs. So I have a pair of 3's with a 2 left over. I've got a pair of a's with an a left over, and a pair of b's. So we brought out a 3, we brought out an a, we brought out a b, and what's left underneath my square root is a 2a. Alright, now the trick, okay? I know I'm looking for pairs, so all I've got to do is I've got to take this number, divide it by 2. The closest whole number is what's going to be taken out. So 3 divided by 2 is 1.5, so we know we're going to have 1 left over. Okay, so I brought out 1 and I have 1 left over. Here I've got y to the fourth. Well, y to the fourth, take 4 and divide by 2, I get 2, so I know y squared is coming out. Okay, or think of it in terms of socks. If you have 3 socks, you've got a pair of socks with 1 Lone Ranger. If you've got a pair of x's, you've got a pair of, if you've got 2 x's, you've got a pair of x's or a pair of socks. Okay, so it's going to be 1 pair outside the radical. So with that being said, I've got m to the 5th here. Okay, so we know we have m times itself 5 times. So if I have 5 socks, I've got 2 pairs with 1 left over. Okay, or I could write it out, expand it out, and say I've got m 5 times. Well, I've got a pair with 1 left over. Same thing. If you've got n to the first, you have no pairs. It's got to stay underneath the radical. Sorry, we're looking at the cube root, Coach Sapp. Gets me every time. So the cube root, if we have 5, again we have 5 m's. Now we're looking for 3 of a kind. So I've got 3 here. That's going to come outside. 2 left over. Looking to break down 81. 81 breaks down into 9 and 9. 3, 3, 3, and 3. So we have that outside with a 3 left over. Alright, so here we've got 3m outside. We've got the cube root of 3 m squared n. Alright, going back to our square root, so we're looking for pairs. So square root of 75, 15 and 5. Okay, so again, break down 15 into 3 and 5. So we know we have a pair of 5s. That's going to come outside the radical. We know we have this underneath the radical, so square root of 3. Now again, you have 4 socks. You're looking for pairs of socks. So you've got 2 pairs with none left over. So a squared outside. If you have 2 socks, b squared, you have 2 socks. You have a pair of socks with none left over. So b. And then if you have 1 sock, you have no pairs. So it stays underneath the radical. Here we go, looking for cube root. So we're looking for 3 of a kind. So that 8 breaks down into 4 and 2. That 4 breaks down into 2 and 2. So we know we have a 2 coming outside the radical. X squared, so you only have 2 socks. You need 3 socks. So it's got to stay underneath the cube root. Here I've got 5. Okay, I can take a y outside. And I know I have 2 left over. So I've got underneath my cube root, I've got x squared. I've got 2 left over from my y, so y squared. I've got z to the third. Okay, if I want to expand that out, if you've got 3 z's, you're looking for 3, so perfect. You have none left over. So it comes outside the radical. So we brought a 2 outside, we brought a y outside, we brought a z outside, 2yz. Underneath the radical, we've got x squared, and we've got y squared left over. All right, looking at number 24. Okay, we've got a fraction. Got a fraction inside my radical. What we can do is we can separate that and say that's the square root of 9 over the square root of 16. All right, now we're going to reduce the top and we're going to reduce the bottom. The square root of 9, we know 9 breaks down into 3 and 3, so the square root of 9 is 3. 16 breaks down into 4 and 4. So my answer is 3/4. Same thing here. I could say this is the square root of 121 over the square root of 64. Well, the square root of 121, that's a perfect square. That's going to be 11. The square root of 64 is a perfect square. It's going to be 8. Same thing with number 26. We get the square root of 225 over the square root of 9. Right? So all we're doing is we're going to separate it out. So we separate it out, 225 on the top, square root of 9 on the bottom. Square root of 225 is 15. Yes, 15. Square root of 9 is 3, so we got 15 over 3. Here we're going to separate this out into the square root of 100 over the square root of 144. We know the square root of 100 is 10. We know the square root of 144 is 12. Now we can reduce that fraction. Both of those are divisible by 2. So this becomes 5 over 6.